Hello everyone. In this session, let us try to understand how we can frame regular expression for strings not containing ABA as substring. Now, as usual, basically, first of all, we are supposed to design DFA for strings containing ABA as substring, that accepts strings containing ABA as substring. So let us first design DFA for that. So we start with Q0, the starting state, then A, it moves to Q1, then on B, it moves to Q2, then again on A, it moves to Q3, where Q3 is our final state, and after that, it can take any number of A's and B's. Now, let us complete the DFA design first. Now here, upon B, it stays on the same state. Next, upon A, it stays on the same state because A, B, A. Then here, upon B, it goes back to Q0, and upon A, it goes to final state. Now that all the states have dealt with all the symbols, and this is for symbol set A, comma B. A, comma B. Now that we have completed designing DFA for the given problem statement, now what we have to do is we have to revert the states. Now whichever the states are normal, we have to make them as final state, and whichever the states are final, we have to make them normal state, and initial state will be initial state. Now let us convert this. Okay, Q0, this becomes final state as well as initial state. Next, Q1, this also becomes final state. Then we have Q2, this also becomes now final state, and Q3 becomes a normal state, and all the inputs remain the same. Okay, so this I'll write here. Now B, then A, and this is A, this is A, comma B, and this goes back to Q0. Now we have fully reversed the design DFA. Now you can see from this DFA, this DFA, this is a trap state. On A, it goes to a state wherein it goes into infinite loop. It is a trap state. So we do not require trap state. So what we shall do is we shall take it out from the DFA. Okay. Now this DFA became finite automata because Q2 is not dealing with A, but it is an automata, finite automata. Now let us start framing the regular expressions. Now let us make Q0 as final state, and all other states we have to make them as normal state. Now the finite automata becomes like this: Q0, okay, then Q1, then Q2, and this is B, this is A, this is B, this is B, and this is A. Now Q0 is only considered as initial state as well as final state, and Q1, Q2 are normal states. Now next is, let us remove Q1. This is called a state elimination method of building a regular expression. So we have to eliminate states one by one. Now I will eliminate this Q1 state. Then what happens? This becomes Q0. This remains as it is. Now Q1 has gone. So direct connection to Q2. Okay. Now it is A, this A. Now this whole set becomes like this A star, and this B will take me to Q2. And from Q2 I can come back to Q0. Now we have a automata which has only two states. One initial state, one final state, and one normal state. But for us now, for this case, we have made Q0 as only the final state. So we need Q0 only at the end. That means once again we have to eliminate Q2. If we eliminate Q2, what remains is this Q0 initial as well as final state. So this will be the B. Now this, when we remove this state, okay, these two gets clubbed. That is A star, B and B. Now that we have totally removed all the normal states and we have only initial and final state, that is Q0. Now we have to build regular expression for this particular case. That is, we can call it as regular expression 1, which is equal to either B, okay, or this one. We have two loops, so there comes an OR B plus A star BB. But you can see both are self loops. This is also self loops. So what we can do is we can put a whole star to this. Now that we got our first regular expression, so let us continue and try to generate more regular expressions, and after that we can integrate those regular expressions. Okay. So I'll erase this part. Okay, now let us make Q1 as final state and other two states remain normal. So that gives us Q0 initial state. There is a B. Sorry, this is not final state. Sorry, this is only initial state. Okay. Next, on A, it moves on to Q1. Now Q1 is final state for us, and upon B, it moves to Q2. Q2 is a normal state for us. Now same thing, A, and from here we have a B transaction, and this is our modified finite automata. Now this is initial state, we cannot remove this. Now let us eliminate Q2. If we eliminate Q2, what we get is we can combine these two. Okay, so that results into, I will write it here only. I have space here, I'll write Q0, okay, upon A goes to Q1. Now I have removed this, okay. Now this A remains as it is, it was there earlier. Since I remove this, okay, this whole setup will be B, B. Okay, and this B will be there, A will be there, and rest all things are fine. Now see, we have one initial state and one final state, and that's what we in the state elimination method, above this or beyond this we cannot minimize, I mean we cannot eliminate. We need one initial state and one final state. Okay. Now since the initial state and final state are different here in this case, in the earlier case both the states were same. Okay. Here they are different. So what we can do is we can use one formula, standard formula, that is regular expression is equal to R plus S U star T whole star S U star. Now in this, I'll tell you what R, S, U, T are. It will be like this. Any state, you take any state. Okay. This is R. This is S. This is U. And this is T. So R, S, U, T. Okay. Now this is the standard formula that we have. Now look at this automata and this automata. Okay. Now here see we have B, we have A, we have A, we have U, okay, and we have T. Now represent this over there, that becomes, I'll erase this or I'll write it here only. RE is equal to, what is R? B plus what is S? A. What is U? A star. What is T? BB whole star. Okay. Next, what is S? Once again A. And what is U star? U star, that is A star. Okay. Now we got our regular expression. Here is this part. And also, now I will put my regular expression 2 here. B plus AA star. Okay, AA star. BB whole star. AA star. So we got our second regular expression. Okay. Now let us move on to the next step. Okay. This time we'll make Q2 as final state. That means these two will be normal states. Okay. Now Q0. So this is normal state. Q0 upon A, Q1 upon B, Q2, but Q2 is final state this time. From Q2 it goes to Q0, and this is B, and this is A. Now, since Q2 is final, Q0 is initial state which cannot be replaced, I will eliminate Q1. So if I eliminate Q1, what do I get? Q0 on B. I'll eliminate this, so directly I can reach Q2. So how can I reach Q2? It is A star, B, and from Q2 I can reach back to Q. Now once again we have come across a situation where we have one initial state and one final state. Okay, so once again let's apply that formula and we get the regular expression 3, that is R, that is B, plus AA star B. There is no U symbol, so this becomes null star. Okay, null star. Then UT, T is B. Next, whole star. Then S into U star, that is AA star B, and that is U star. It's null. So this gives rise to B plus AA star B. Null star is epsilon. Epsilon into B is B whole star. AA star B. Once again, null star is epsilon. So we got our third regular expression. That is equal to B plus AA star BB whole star AA star. Is that clear? So we got all three combinations of regular expressions. Now we have to integrate them. So I'll erase all these things. Now let us write the final regular expression. Regular expression RE is equal to B plus AA star B whole star plus B plus AA star BB whole star AA star plus B plus AA star B BB whole star into AA star, and this is our regular expression for the given problem statement. Now this you can further simplify, or you can keep the answer at this level. That is also accepted. Hope you understood. Thank you.